Hello class, welcome to lesson 10.4, which is all about the Pythagorean theorem. By the end of this lesson, you should be able to use the Pythagorean theorem to find the length of a side of a right triangle, as well as use the converse of the Pythagorean theorem to determine if a triangle is a right triangle. Something very important for you guys to know is we use the Pythagorean theorems with right triangles. It's easy to try to use it with any triangle you see, but remember, we are talking specifically about some right triangles here. Okay, so looking at a picture of a right triangle, up top here we see that we have two sides that are called the legs. Note that the legs touch that right angle, okay? And then our third side is called the hypotenuse. The hypotenuse is always the longest side of a triangle, so our longest side, and it is opposite from our right angle. Okay. So if you are talking about the Pythagorean theorem, we have a triangle. If you look down here, we call the shortest side A, the middle length B, and then our longest length C. So the Pythagorean theorem, make sure you write this down somewhere. You are going to want to memorize this because it will make your life so much easier if you know it. We have A squared plus B squared equals C squared. So if we take the length of our two legs and we square each side and add them together, those numbers should add up to the square of our hypotenuse. Okay, so let's try a couple of problems like that and see what does that look like. So we want to find the length of our hypotenuse. So look, I have my right angle here. My hypotenuse is going to be opposite from my right angle. And you can see I'm using the letter C to represent that. So my Pythagorean theorem was that A squared plus B squared equals C squared. So my A squared is my shortest side, so 20 squared plus B squared is the middle length, so 21 squared equals C squared. Okay, so if I do 20 squared, I end up with 400. Plus 21 squared gives me 441 equals C squared. We don't know what that C value is. So 400 plus 441 gives me 841 equals C squared. And just last week we were talking about how do we solve something when it has that squared? How do we undo that square? We take the square root of both sides. So I have the square root, don't forget your plus or minus, 841 equals C, because I undid that square with the square root. And then if I calculate out what is the square root of 841, I'm left with 29. And technically you're supposed to carry down that plus or minus. But let's think about, does it make sense to have a positive 29? Yes, because we're talking distance here on a triangle, right? But so positive 29, that answer's okay. What about a negative 29? Is it possible to have negative 29 feet? No, so we throw that negative out, and we know that C is 29 feet long. And if you compare 29, that is our biggest side of the triangle, so it works. Okay? Why don't you try one on your own, see how you do. Hopefully you ended up at 5 meters. You should have set it up 3 squared plus 4 squared equals C squared. So you would have had that 9 plus 16 equals C squared, or 25 equals C squared. The square root of 25 gives you 5. All right. If you have any questions, please be sure to ask for some help. All right, example 2, we were talking about a ladder is positioned against a 10-foot building and it reaches its top. Its base is 3 feet from the building. About how long is the ladder in feet? Round to the nearest tenth. Okay, so we have some descriptions, but no picture. When you have a word problem like this and you're talking about a triangle, go ahead and draw yourself a picture, and that will help you to determine how to solve this problem. This picture is maybe a bit more detailed than what you needed to do, but if you at least do something like this, that will help you solve for the answer. So we have that 3 squared plus 10 squared equals c squared. So 3 squared, that gives me the 9. 10 squared is 100 equals c squared, or 109 equals c squared. And again, if I take the plus or minus square root of 109 equals c, if I simplify that, I'm left with about 10.4. I can get rid of that negative 10.4 because I can't have a negative 10.4 foot ladder. So I would say my ladder is approximately 10.4 feet. Okay, because remember, I'm rounding to the nearest tenth. Okay, why don't you try one on your own? Hopefully you ended up at 11.3 feet. So this time we had an 18-foot tall ladder was placed against a building which is 14 feet tall. We wanted to know how far the base of the ladder was from the building. So this time we had 18 here, 14 here, and we wanted to solve for that value. So we had a squared plus 14 squared equals 18 squared. And from there, you would solve, you would move, you'd have a squared equals, and if you did 18 squared minus 14 squared, I don't have a calculator on me right now, so I'm not calculating that out. But you know, those are each a number. So if you say a equals the square root of whatever 18 squared minus 14 squared is, that's where you should end up with that 11.3 feet. Okay? So that one involved solving a couple more steps where you had to get a by itself, because in the last examples, c was already by itself, but this time we had to get our variable by itself. All right, example 3, we are talking about a diagonal path through a rectangular garden. Okay, so a rectangular garden, I'm going to draw myself a picture. We have a diagonal path going through it. Is 32 feet long, so my diagonal is 32 feet. If I have a rectangle, I know these are all 90-degree angles. The length of the garden is 24 feet, and I want to know about how many feet wide is the garden. So I want to know what is that distance right there. So I can say w squared plus 24 squared equals that 32 squared. So w squared plus 24 squared gives me that 576 equals 1,024 for w squared. If I subtract 576 from each side, I'm left with 448. W equals the square root of 448, or w equals 21.16601,049, which that gives me approximately, if I'm rounding to the nearest tenth, I would have 21.2 feet. Okay, so I went through that kind of quickly, so let's go back and look. I set up my equation with my diagonal, you know, the one across from that right angle, my hypotenuse, is on its own side of the equal sign, so I have 32 squared, and then it equals that 24 squared plus that length that we didn't know yet. Then I just took the square of both my 24 and my 32s and substituted what those are. I subtracted 576 from both sides. I'm left with w squared equals that 448. I wanted to undo my square, so I did the square root. And once I took that square root, again, I'm looking at the plus and minus, but I'm only interested in the positive answer because we can't have a negative distance. So that was about 21.16601,049. So if I round to the nearest tenth, like we have been doing, it's approximately 21.2 feet. All right, why don't you go ahead and solve this one on your own? Hopefully you ended up at 26.5 feet. Again, we have a rectangular garden and a diagonal path going through the diagonal is 40, and the length is 30, okay? And you are solving for that width. It's the same process. I'm not going to do this whole thing, I'm just going to set it up for you. So then you would solve from there. Okay, example 4. This is where we're going to use what's called the converse of the Pythagorean theorem. What the converse of the Pythagorean theorem means is you can use the Pythagorean theorem, you can use it to determine if the triangle you're looking at, if the three sides you have, if they form a right triangle. And the way we know that is if we take the two smaller sides and we add them together, it should equal that longest side squared. But if it doesn't equal, then it's not a right triangle. Okay, so let's try that. We have our two small sides for letter A are 48 and 60. So we have 48 squared plus 60 squared equals 78 squared. I'm going to put a question mark above the equals because I want to know if that's true. So 48 squared gives me 2,304. 60 squared gives me 3,600. So if I add those together, I get 5,904. And I want my 78 squared to equal that number. But when I type 78 squared into my calculator, I get 6,084. Since those two numbers are not equal, I say this is not a right triangle. Okay? Since they didn't equal each other, they are not a right triangle. Okay, let's look at our next one. We have 24 and 70 are my smaller sides, and I want to know, do those equal our longest side squared? So 24 squared gives me 576. 70 squared gives me 4,900. And if I add those together, I get 5,476. And if I take 74 squared, I get 5,476. So I know this one is a right triangle. Okay, why don't you try to determine if the measures of these three sides form a right triangle? Hopefully for this first one you said that it does not form a right triangle. They do not equal each other. And try one more. Hopefully for this one you ended up saying that they do form a right triangle. If you have any questions about that, please be sure to work together, try to work through what questions you have, ask for some help. But anyways, I hope you guys have a fantastic day.